All right, unit 3.3. This one should be interesting. I know it's going to be different and you're going to actually have to think, but I need you to focus. 3.3 and try to learn with me. Just do your best. I know it's probably something you've never seen before. All right, we looked at the domain and range in our last video. Right? We looked at continuous graphs in our first video. And now we're going to try to find the domain and range of continuous graphs. In some cases, the range is all numbers because it goes on forever in every direction. We just have to figure out what the range is, right? So, for domain, scan your pencil left to right. Remember, domain is your x-axis, your horizontal. Scan your pencil left to right. And identify the x values in which you are touching the graph. So you have to think bigger than the graph. You have a tiny piece of the graph. Sometimes that tiny piece is enough. Sometimes it goes on forever. And you have to imagine it goes on forever. Right? So you have to think and ask yourself, if this keeps going forever, what x values is it going to hit? It's going to hit this one, this one, this one, this one, this one, this one, and forever. It's going to hit this one, this one, this one, this one, this one, this one, and forever. Right? It's going to hit all of the x values. So literally your answer is all real numbers. I told you sometimes the answer is literally all real numbers because it goes on forever. Now, this is where you have to be careful. For range, scan your pencil up and down and identify the y values in which you are touching the graph. It says touching in quotes because even though the line specifically touches the x-axis here, it touches everywhere because it'll cross eventually, right? So the range, let's figure out where our range is. Let's start right where the point is because that makes the most sense to me. It touches the y-axis here. It's going to touch here, 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 and forever in that direction. But it's not ever going to go below that point. Get it? It's going to go up forever, but it's never going to go below this point. And this point, because this is the origin, -1, -2. That's a -2. Right? So, it's never going to go below -2. Y has to be greater than or equal to -2. It's never going to go below -2. It's impossible. It stops right there at -2. That's your range. Your range is all numbers greater than or equal to -2. Told you it's different. Rewind, watch it again. Rewind, watch it again. Think about it. Visualize the bigger graph. It's not just this little thing. It goes on forever. That direction and that direction, which means it goes up forever in that direction. All right, what about number 2? This one's not going to go forever. It's a circle. So on the x-axis, it's going to hit this one, this one, this one, this one, this one, this one, and this one. And that's it. So it's going to be somewhere in between +3 and -3. That's all you know. Somewhere in there are all the possible answers. So x has to be greater than -3, greater than or equal to -3, and it has to be less than or equal to positive 3. X is in the middle of 3 and negative 3. It's greater than negative 3, but less than 3. It's in the middle. Alright? Same with your range. Let's change the color. Your range on your y-axis, it's going to hit here, 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 and here, 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 and here, and no further. So positive 3, right, is your outer limit here, and negative 3 is your lower limit, right? So your y has to be greater than or equal to negative 3, same, because it's a circle, right? And it has to be less than or equal to positive 3. Your x's all have to be on this line or inside the circle, and your y's all have to be on this line or inside the circle. Different, I know. Watch it as many times as you need to. Alright? I'm going to work the even ones, and you are going to work the odd ones, because somebody told me that the even ones are harder and I should be working the even ones. You can thank whatever student that was. I can't remember. I'm pretty sure they don't want to be called out anyways. Alright, so where does it hit the x? Right? It's going to hit here, 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 forever. Here, 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 forever, because it goes on forever. It'll eventually hit all of the x values. So, again, all real numbers. All real numbers. Now, range. Because it goes on forever this way, it's going to hit all of those. And it's going to hit this one, and 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 that's it. It doesn't go any higher than that. So this is the maximum. And that's 1, 2, 3, 4, 5. That's positive 5. Right? So y cannot be greater than positive 5. It has to be less than or equal to positive 5. Those are the limits, the outer boundaries. Ooh, that one's interesting. All right, we might have to think about this one for a second. Okay. So on this, it's going to hit all of these, and it's going to go forever in this direction. So it's going to hit all of these. And it's going to go forever in this direction, so it's going to hit all of these, all real numbers. And the range, well, it looks like it goes forever in both directions. So, all real numbers. I know. They begin to make sense after you look at them enough. You'll just be able to look at them and be like, oh, well, it goes forever in that direction, but it stops here. So we know our x has to be greater than or equal to -1, because that's -1. See, the more we do it, the better we'll get. And we know that it eventually goes that way forever, and it eventually goes that way forever. It's going to hit all the y's. All real numbers. It's going to hit all the y values. You have to imagine it going on forever. All right. That's an interesting one. I almost didn't see the line. You see it? It's right here. It's going to hit all the x values. All of them. Right? Because it goes on forever. All real numbers. But what about the y value? Where is that? 1, 2, 3, 4. It's at -4. It's not going to go over -4 or under -4. So literally y has to equal -4. That's the only thing it could equal. That's the only thing it could equal. All right? Ooh, interesting. They're connected, but it doesn't continue on forever. It's neither discrete nor continuous. I don't know what it is. I'm sure it has a name. This is why I don't teach upper level algebra. But I can tell you that for the x values, it's going to hit here, 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 here. So 1, 2, 3, 4. This is -4. 1, 2, 3, 4, 5. This is +5. I know x has to be greater than or equal to -4, less than or equal to +5. I know that much, right? And then for the y values, I know its lowest point is going to be here, and its highest point is going to be here. It's going to hit everything in between. I found its lowest point and its highest point. So I know the y, 1, 2, this is a -3, has to be greater than or equal to -3. 1, 2, 3, 4, 5, this is +5, and less than or equal to +5. I found its lowest point, highest point, and then its lowest point, highest point. And then I just said what they were. Last one. Well, for me, you have to do the odds. I did the first one for you. You're welcome. Oh my. Well, on the x, it doesn't go further than this, because it's right there, it stops. But in this direction, it goes forever. So x has to be greater than or equal to -2. And its lowest point for its y is right there. Same dot, same point. And for the y, it continues going up, right, up, right, up, right. So it's going to go forever. So y has to be greater than or equal to 1, 2, 3, -4. Just like that. I looked at it and I was like, that's weird. And then I realized, nah, it's super easy. Because it stops here. It doesn't go any lower than this on the x-axis, and it doesn't go any lower than this on the y-axis. That's actually easy. At least I can visualize that. It's on the graph. All right, you do the odd ones when you feel like you're ready. Come get your mastery check.